Welcome back to this course, where we'll be talking about Profinet communication with inverters for the FR-E800 range. The models suitable for communication in Profinet are the FR-E800E or the FR-E800 SCE, if the safety function is also required. It is essential that both have the code ending EPB. The table shows the various Profinet protocol data, such as communication speed, type of cable to be used, I/O device category, and possible network topology, both inline and star. Let's now talk about telegrams, that is, data packets exchanged between Profinet devices. There are mainly three. Telegram 1, also known as speed control, is the simplest one. With this telegram, the exchange area is made up of 4 words, 2 for writing and 2 for reading. As shown in the table, the first write word is the control word, while the second is dedicated to writing the speed set point. For reading, the first is the status word, while the second is the speed actual value. The second telegram we're going to look at is telegram 100, also known as torque control. It consists of 6 words for data exchange, 3 for writing and 3 for reading. The 3 write words are, respectively, the control word, target torque and speed set point, while the 3 read words are the status word, actual torque and speed actual value. Now we'll look at telegram 102. It's customizable and allows you to exchange a lot of data, 11 words for writing and 15 for reading. Customizable means we can configure the telegram via the inverter parameters dedicated to data exchange, based on the data we want to share with our master. You need to enter, in the parameters, the PNU number for the data to be read or written. For writing, you need to use parameters 1320 to 1329, whereas for reading, parameters 1330 to 1343. The inverter parameters required for Profinet communication are as follows. 79, operation mode selection, to be left at 0. Parameter 340, communication startup mode selection, to be left at 10. Parameter 1426 can be set if the user wants to change the communication speed. My advice is to leave it at 0, as it can automatically detect the communication speed between the master and the slave. To conclude, parameter 1429 must be set to 3 for 962. This allows you to open the inverter's Profinet port. I've also included the speed calculation for the FR-E800. This refers to parameter 1 or 18 of the inverter, i.e., the maximum frequency, and I've provided the formula needed for the calculation. After configuring the inverter, you need to set up the master communication. Here are the steps required. Let's start by installing the GSDML file. Here's the path to add it to our software. Remember to choose the correct file for the inverter model you're using. This table shows that for a standard Ethernet inverter there's a specific GSD file, whereas for the safety or IP67 models there's another dedicated file. The second step involves adding the inverter to the project. After creating a new project and inserting the CPU, you can open Device and Networks. Here, in this Network View tab, you can add Profinet nodes. You need to select the node linked to the FR-E and drag it into the project. In the Hardware Catalog, under Other Field Devices, you and #X27 LL find Profinet I/O, drives, Mitsubishi Electric and FR-E800 inverter. By dragging the Profinet I/O reference device element from the FR-E800 folder, the GSD file is added to the network. Although the node isn't an #X27 T connected to any Profinet network, clicking on Not Assigned, highlighted in blue, brings up a menu to select the desired network. An IP address is generated automatically. By double-clicking the inverter in the network view, you access the device view. Here, you need to import the telegram to control the inverter. In the device view, you can change the IP address of our slave and also the device name. The name can be found under Properties, General Ethernet Addresses. To start communication between the inverter and the CPU, you need to configure the IP address and the device name via TIA portal. Follow these steps. Go to the Communication tab in Online Access. Click Accessible Devices to view the devices on the network. Under FR-E800, in Online and Diagnostic Actions, set the IP address using the Assign IP Address button. In Assign Name, assign the Profinet device name. Make sure the name matches the one in a device configuration. After configuring the PLC, we check whether communication is working by checking the LEDs on the inverter. The NS LED must be green and on, as must the MS LED. Also, the Link 1 LED or the Link 2 LED must be on, depending on which Ethernet port is being used to communicate with the Profinet master. As an example program, I wanted to bring along the function block that we supply to customers for inverter control. It will be possible to command the inverter when we have that inverter ready feedback set to true, the fault signal must be set to false, and the iSetPoint field filled in with the frequency we want to deliver. At this point it will be possible to command the inverter by enabling the X-Start POS or X-Start NEG signal depending on the desired direction of rotation. Do you need more information? We're available by email or phone.